So today, the last session here is about comparing or giving a little bit of an overview between different solutions, such as Percona XtraDB Cluster, Galera Cluster, and MySQL Group Replication. So that's kind of the subject of the talk. So this is Ramesh. So
hello. Yeah, I'm Ramesh. I work in Percona as a QA engineer for PXC and multiple other technologies, databases, Percona server, then some tool set like PMM. That's it.
Perfect. And I'm the a MySQL practice manager at Percona. Also working on various things on the services organization as opposed to the engineering organization with Ramesh. So let's get started. We have a lot to cover. Let's start with the beginning, a little bit of an overview with those three technologies that I'm going to try to compare a little bit today. So let's start with the first one, or maybe a small question for everybody. Who is using Galera Cluster at this moment in production? 2. Okay, who's using Percona XtraDB Cluster as in production at the moment? Nobody?
No.
Okay. Who's using, Alex, of course, and who's using group replication in production? Nobody. Okay, good. Okay, good. So a little overview for the people that don't know what it is. This is kind of like a copy-paste, so I'll add some little notes to this. So Galera Cluster is a technology, an open source technology developed by a company named Codership. So you'll have their website there. It's currently a thing that is included in MariaDB at the moment, and I'll talk a bit more about PXC, which is similar. But what the main thing of what Galera Cluster is, and this is according to their website, is that it is a synchronous multi-master database cluster based on synchronous replication and Oracle's MySQL/InnoDB. And you can direct reads and writes to any node. You can lose an individual node without any interruption and without having to do any kind of complex failover or like have any tools that needs to do failover or anything like that. Now I have one note that I need to add because some wordings are quite sensitive, is that it mentions that it is a synchronous multi-master database. However, keep in mind it doesn't mean that it's like that everything is synchronous. It's not because you write a transaction on one node that the other nodes will immediately have that transaction available. The replicating part is synchronous. The application or applying these things on the other nodes is still kind of asynchronous. And this is important, especially when we go into compare the three different technologies. They might use different wordings on their website, but they might not mean that it actually is like that, or yeah. So I'm trying to be neutral here in comparing these solutions. So keep in mind it's replication that is synchronous applying asynchronous. So that's kind of it. I'm not going to go and say like this is Galera, this is PXC, and this is group replication. This is how all the inner workings kind of work. Now, small thing about Percona XtraDB Cluster, it's basically Galera Cluster, but we add some things to it. So Ramesh is working, Krunal we have there is developing Percona XtraDB Cluster, and basically we take Galera Cluster, similar to how we take MySQL, and we add features. We do this in Galera Cluster. So we have a lot of additional features. So we have better performance schema support, for example. We have extra backup changes, the way to provision nodes, SST, so state snapshot transfer. I'll talk a bit about that later on. Is different compared to Galera. We have some bug fixes that we make, which are not in Galera Cluster, because we have support for PXC, so therefore we provide bug fixes on our own. We also have some that I'll talk a little bit more about in the slides, as they are really distinguish the difference between Galera and PXC, as there is now a difference at this moment. So in the last couple of months, and especially with PXC 5.7, there has been some differences between those versions of what Galera Cluster is and what Percona XtraDB Cluster is. So more specifically, the strict mode, integration with ProxySQL, and then what we recently released last week is the performance enhancements. Now going to group replication, so MySQL Group Replication is something developed by MySQL, by Oracle MySQL. It's something that went GA in December 2016 in MySQL 5.7.17. So if you're using MySQL 5.7.17, it's in there. It's a plugin. It's basically a plugin that you load and you have group replication, kind of. Now, there's a distinguishing thing between group replication and MySQL InnoDB Cluster. So some of you have seen that are on my tutorial together with Fred and Matt Lord on Monday, is that MySQL InnoDB Cluster is more a solution and is a combination of various things, which includes group replication. But more on that next slide. So what does MySQL write? So MySQL Group Replication is a plugin that provides distributed state machine replication with strong coordination between servers. So servers coordinate automatically, and they process, any server can process writes, can process updates. There's conflict detection in there, and conflicts are handled automatically. It's built-in membership service, and nodes can join and leave the group automatically. So it's not the same as what we here have, what Galera wrote down, but it's kind of similar. If you read it, it is kind of similar. However, there are some differences, of course, and hence this kind of presentation. MySQL InnoDB Cluster. So on the bottom, we have MySQL Group Replication, which is that way of replicating data between nodes. And InnoDB Cluster contains something more. It contains the MySQL shell, which you have to use or can use in order to automatically configure group replication, to add nodes, remove nodes, change configuration, and so forth. And MySQL Router, which is a layer 7 or a load balancer, basically, that load balances the traffic to which node is currently the active master, or to multiple masters if there are any multiple masters. So this is MySQL InnoDB Cluster. Now, before I go into the differences, I'll talk a little bit more about what they have in common. And there's quite a lot of things that that they have in common. So it's MySQL based. That's the first, or MariaDB. So MariaDB Galera Cluster is based on Galera Cluster, of course. It's a way of replicating data. So yes, the name cluster is in the name, but it doesn't mean that it will automatically scale out your database. It doesn't do sharding or anything of that. Both these technologies do not provide that. So it's all nodes have all the data. Keep that in mind. So it's just a way of replicating data. So when I do reads on a node in both three of those solutions, the reads will just run on the local node, and there's no communication happening between the other nodes of the cluster. If we do writes, then some coordination or some communication is necessary. They all require InnoDB/XtraDB. So XtraDB being the Percona version of InnoDB. So it contains some additional features and enhancements. So that is required. So you can experimental support have MyISM support for Galera Cluster and Percona XtraDB Cluster, but it's not recommended. There are a lot of issues with this. It's just an alpha. It's not a stable feature. And I don't think that this will come in the near future. The same with group replication. It will only work with InnoDB. It's active-active multi-master, so you can actually write to all the nodes at the same time. So that is a key feature. Although in practice, it may not be like that in the default, because group replication by default only allows you to write to one node, and if that writer node dies, it automatically chooses another leader, which then becomes read-write. That's the default configuration, but you can change that. You can set it to multi-writer. However, they do not recommend that at this moment due to some issues, which I'll talk about later. Both of them have a kind of a node membership. They can join a cluster, and then immediately they know all the other members in the cluster, and they will communicate with them. They will leave the cluster in case there is a network partition and take the necessary kind of action in order to make sure that there is like data consistency. So to avoid split brain, so all these environments are quorum based. So if a node doesn't have quorum, so it doesn't see more than 50% of all the total nodes in the cluster, then it will basically impact some things. And it's different between those environments, but I'll talk about that later. So they ensure that writes happen in a kind of global total order. So there's some communication happening, which is very different between the two solutions, where that writes in the cluster will be totally ordered in some way. So it provides data consistency, so if a node dies, the other node still has all the data. It doesn't mean it applied all the data, but it still has all that data in its relay log or Gcache, so in various buffers. It's using a form of optimistic locking / first committer wins mechanism, in that when we do a transaction, during a transaction, I can do begin, I can do insert, update, delete, whatever, I can do all my statements. There is no communication with the other nodes during that transaction. Only when we commit the transaction, it will coordinate with the other nodes in order to see, can I execute this or not? And it takes the necessary action to ensure that there is no conflicts between them. So quorum, I mentioned already, is in order to prevent split brains. So some use cases that I see as valuable, that's my opinion here, is that I recommend these things when you have strict durability requirements. You cannot lose any transaction. With asynchronous replication, you can lose data if the master dies. You could use semi-sync in order to reduce that, in order to avoid that. But that's kind of another way that you could do that. Some companies do this, but in this case, this is kind of built into the whole architecture of all these technologies, is that there is durability. So you can write to all the nodes simultaneously while keeping the data consistent. If you have master-master replication with asynchronous replication, you can also write to both nodes at the same time, but there is no guarantee that there will not be any inconsistencies. It's something you have to figure out yourself. It might give you errors in replication, or it might basically not give you any error and create inconsistencies. So that's important. And environments that want to reduce failover time. Failover is very fast in this environment, because there's no external script that needs to monitor or pacemaker that you need to run on top in order to choose a new leader. It's built into the whole mechanism, into the cluster software, to choose who can write, who can read, and so on. There are some limitations to all of these environments, and it's very important that before you go and put these things in production, you will test that, of course, but large and long-running transactions are not recommended in any of these solutions. So the larger your transactions are, the more chances that you will have conflicts if you write to multiple nodes. If you write large transactions, there's also a lot more overhead in terms of network, and that is not really optimal at this point for both environments. Like if you update 1 million rows, it might actually not work. It actually doesn't work in Galera Cluster. But updating 1 million rows means that when we commit the transaction, it needs to send all that data to all the other nodes. They need to process that. They need to certify it, and then apply it. So large transactions really not a good thing. Another thing with writing to multiple nodes at the same time is hotspots. If you have certain rows, certain tables, the same roles that get updated frequently on multiple nodes at the same time, you'll have more conflicts. And you'll get errors, you get rollbacks, because transactions need to be rolled back in order to do that optimistic locking and to ensure that data remains consistent. So the best way to solve most of these issues is to write to a single machine, so a single node. And that's the default in MySQL Group Replication. In Galera, you can always write to all the nodes, but then you would handle it yourself, or you use a load balancer to ensure that I only write to one at the same time, to one node at the same time. Now, a little bit about the differences between these solutions, more specifically, I'm going to talk about differences between group replication and Galera-based replication. So this includes Galera Cluster and Percona XtraDB Cluster. And then as a next section, I'll have what's the difference between Galera and Percona XtraDB Cluster. So there's a lot of differences. I'll go over all of these. So first and foremost, the communication layer that is under that fuels this way of this cluster software is the group communication system. And Galera uses something called totem single ring ordering, and that's a kind of a mechanism in order to do the communication to ensure that when a transaction is written on one node, then they acknowledge that all the nodes have received it. So it also is a way to know how to send the messages, how to reach the other nodes, and so on. I'm not going to go into the specifics of this. That's like a talk on its own. But important to know is that when I write something in Galera Cluster or Galera-based systems, all the other nodes in the cluster need to reply and acknowledge that they have received that event. And once they all acknowledge that, so that's one round trip, then the commit is deemed successful, and it will continue by committing it on the local node and then returning OK back to the application. Group replication is different here. Group replication is using XCOM, which is a Paxos system. It's similar to Paxos Mencius. That's kind of what they're saying, but not quite the same. So there are some differences. It's not straight out Paxos, but there are many, many Paxos variances. But the important thing is that the difference here is, if we relate that to Galera Cluster, is that Paxos does not require that every node returns the acknowledgement. It's okay. Paxos protocol will basically ensure if a node writes something, that if the majority of the nodes return the acknowledgement, then it's okay. We can guarantee that that transaction will be delivered to all the nodes, that the data, that the cluster will remain consistent regardless of what has to be done, and the transaction will continue. So if you have a 5-node cluster, in the first solution with Galera-based, 4 nodes need to return back. With a Paxos system or with group replication, only 2 nodes need to return back, because you have a vote. Your own node is also a vote. So 2 nodes return back. That's 3 in total, which is the majority. So that can be kind of a performance benefit, can be, in theory, right? The next difference is what they used. How do they replicate data? And Galera Cluster PXC uses binary row log events. So they use these row events and they change them and transform and add some data, and they make a write set. So a write set is kind of a transaction. However, it does not require binary logging to be enabled. So you can run Percona XtraDB Cluster with binary logging disabled, and that will still work. Galera Cluster writes these write sets, these binary log kind of events with that additional data, to a cache called the Gcache. So the Gcache is, by default, you can determine how big that needs to be, for example, 128 megabytes, and that's the amount of size that will be used. There are some special cases where the Gcache will grow in order for it needs to operate, but that's kind of like the basic of it. In group replication, it's just based on binary logging. It needs binary logging to be enabled. It needs various binary log settings to be specifically like binary log format. There's some other settings that need to be specifically, like, for example, binary log checksums needs to be disabled before this will work. So binary logging has to be enabled. It's not asynchronous replication, but if for example, if you didn't attend my tutorial, then you can do show slave status. You will see a channel for provisioning of group replication nodes. But if you check in performance schema, there's another kind of like replica thread, which is then the applier thread for group communication. So it's kind of they built it into similar performance schema tables as asynchronous replication. Next difference is node provisioning. So Galera Cluster has automatic provisioning. So if you add a node, it has no data, and you say, I want to add that node to the cluster, you basically just say, join the cluster. You can find the cluster using these IPs. It will try to connect to the cluster, authenticate, and if that works, then SST happens, so state snapshot transfer. There's various methods that you can do, and we recommend to use Percona XtraBackup, is that automatically in the background, a node will be chosen to be the donor, and that donor will then do a backup, either using rsync, MySQL dump, but the best and the least impacting one is Percona XtraBackup. Percona XtraBackup will run and provide the backup to the node that wants to join. So this happens all automatically. It's easy to configure. It's easy to say start, and the node will join, and you have a cluster. So you don't have to do anything. It also has the concept of incremental state transfer, which is when you shut down a node for a couple of minutes in order to do maintenance or something like that, and you start the node, then it will say, okay, I have until this sequence number. This is my state. Can you give me the incremental changes? If it can, it will provide you that. And this is basically determined by the size of your Gcache. So if the Gcache contains that certain amount of data, and if it's not, then it will fall back to SST, meaning that it will trash all the data on its node. It will do rmnrf/varlit MySQL, and then it will start the backup and reprovision the data. And all this happens automatically, which I think is quite nice. It's easy to use. It's easy to set up. Now, MySQL Group Replication has no automatic provisioning. What you need to do is you need to take a backup, restore the backup, make sure GTIDs are enabled, which is the next slide, ensure that that state is okay, and then you configure group replication. And it has an IST, but the IST, the incremental state transfer, is basically asynchronous replication. If I start group replication, it will basically automatically make sure there's a user, replication user, configure the replication user. It will start doing asynchronous replication, and if that node is caught up, then it will stop the asynchronous replication, and it will move into the group replication communication. So these are similar, no automatic provisioning, that's the biggest difference. MySQL Group Replication uses GTID, so you need to use global transaction IDs, so there's no way around it. You have to use it. So it's important, like if we have write to multiple nodes in a certain replication topology, every write you do, basically with GTIDs, there's a UUID. Every server has a UUID and will create event 1, 2, 3. So UUID on my master is master UUID and then 1. 2, 3, and for every transaction, new one comes in. If you suddenly promote a replica to become the master, and then the master becomes a replica, it will be the new or the other host's UUID 1. So you'll form a GTID set, which is a list of server UUIDs with then the ranges of transactions in that it has received. So it uses that, but the difference here is that it's not when you write to another node, another UUID will be used. It will use one UUID, the cluster's UUID. So the cluster, the group replication, basically has its own UID, and that will be used. So you'll see 1, 2, 3, 4, 5 in that, so as a GTID event. Now, if you write to multiple nodes in group replication at the same time, it will be 1 up to 100,000 will be for that node, for the same UID, 101,000 until 200,000 will be for another node. So the sequence of the UUIDs or the numbers does not determine the order that it was executed. That's quite a challenge. So also if you have a lot of nodes and if you write to a lot of nodes at the same time for a long time, those sets the GTID set will become large, and you might need to try to compress this. It might get really, really large, the GTID set. So we'll see how this evolves into when there's a lot more people adopting this and using this, if this will become a problem or not. So Galera Cluster does not rely on GTID. You can enable GTID, that's fine, but internally Galera Cluster just uses a sequence number. So it's basically 1, 2, 3, 4, 5, and it's an ever incrementing number, and that's basically it. Next up is partition handling. So this is quite different, and then there's a lot of things that we need to be aware of and we're talking about network partitioning here. So if Galera Cluster / Percona XtraDB Cluster, if you have 3 nodes and one node loses connectivity with the other nodes, after a timeout, it will notice, okay, I have no quorum, I have a minority, I only have 33% of all the votes, of total of 3 votes. It will automatically, by default, refuse reads and writes. So writes we need to refuse because we want to avoid split brain. Reads we need to avoid because we want to make sure that we return consistent data or most up-to-date data and not stale data. So you can configure these settings, very dangerous, especially if you say, I'm going to allow writes. It is configurable, but you can, for example, reads you can enable if your application is okay with reading some of this tailored data. But by default, it will not. If the network comes back and the third node sees the other nodes again, it will just rejoin and do an IST and see, okay, I want to join again. What happened since I left? And it will just replicate everything and then basically join the cluster again. And that's basically how network partition happens in Galera Cluster. With group replication, this is a lot different at the moment. Maybe it's fair to say that group replication still needs to have some maturity, needs some extra features in order to achieve similar things. So when a node is partitioned in group replication, it will not accept writes, but the writes will hang. So when I write to a group replication node that is partitioned, it will accept the write, it will just hang forever until I join the cluster again. So that's very important. I posted it as a bug. Let's see how that can be resolved, but I see certain problems with this at the moment. Also, it will still accept reads. Reads will be accepted, and there is currently no way to say that, okay, a node has partitions, don't accept reads at this moment. So it does not work. Also, if the network has gone for 10 seconds, then it was partitioned, it will halt the writes or queue the writes. It will not rejoin the cluster automatically anymore. You have to manually do this yourself. So with MySQL InnoDB cluster, you have to log into the shell and say add this node again. Now, if you have a flaky network, I see problems in that because the nodes don't recover automatically. So you only need a couple of network issues and all the nodes will basically be gone and the whole cluster will be down at that time. So that's certain challenges that I've seen so far. I've spoken with a lot of the Oracle people. There's a lot of them here. I don't know if there's anyone here in the talk. And they are working on a lot of these things. So these are not new things to them. They are evolving this at the moment. But it is not here yet. Now, a bit of a different thing. There's a difference between having a way of communicating data or having a full solution that will help and work for your environment. So group replication is basically just a MySQL plugin. It's just a plugin, and it doesn't provide you the load balancing at the moment. It doesn't solve you the issue that we had here that I mentioned before with the partition handling. So there's a lot of things that is currently not there or that you would have to handle yourself, kind of like working around it or adding some scripts on top at this current moment. Now, if you think about, so that's why I call it more, it's like a plugin. It's not there, it's not a fully solution that I can give like as a reference architecture thing. As a solution, I would say Galera Cluster is more like a solution in that it is more safe, especially when we talk about partition handling, split brain, all these things will not happen. So unfortunately, that is the case with group replication at the moment. I'll show you some bugs that I found which are currently at this moment a problem. So I would say Galera Cluster has more of that. It's like a good solution. But it is lacking one thing, is that it doesn't have a load balancer integrated, or it doesn't have a load balancer that will load balance all that traffic at the moment. If we add MySQL InnoDB cluster to the mix, it is kind of like a solution because you have the proxy in front, you have the admin shell, and you have the group replication. So this becomes better because if a node is partitioned, then MySQL router will make the decision to go to the proper environment and will therefore kind of rebalance the workload automatically. Yes, I know work for Percona. However, I really think that currently with the current state is Percona XtraDB Cluster, I see more as a full solution. Why? We really say, and we really strongly recommend when you use Percona XtraDB Cluster, use ProxySQL. ProxySQL is the load balancer of choice that we have chosen, that we support. And we have some integrations that we've started to make that we have to automatically provision ProxySQL configurations based on the nodes. If you add nodes, it will automatically update the ProxySQL configuration as well. And it allows you to then also load balance. You take a node out, ProxySQL will automatically redirect traffic somewhere else. There's also some work done, and I'll show you that when I talk about the other differences, that it will prevent certain features that do not work well in this environment. For example, writing to a table without a primary key is kind of a problem in all solutions. Well, with strict mode in Percona XtraDB Cluster, it will be denied. You cannot run select get lock. That functionality doesn't work, so you get an error back. So all kinds of, or you're trying to create a MyISM table, it will give you an error. Sorry, MyISM is not supported. So there is some work done to make it more user-friendly, to make it more like, okay, this is what you can do, this is, and this is it. If you try something else, it will fail. You'll get an error. While Galera Cluster at this moment just accepts a MyISM table to be created, but it will not replicate to the other nodes. It will support getlock, but it won't. It's up to you to figure that out. So I much rather have an error than have no error and then problems afterwards. Flow control. This is more a specific thing that is in Galera Cluster, is that Flow control is there to prevent that if one node is slowing down because maybe it's overloaded because of traffic or disk I/O gets slower, it's preventing that node goes behind too far. So yes, replication is synchronous, but the application of those transactions is asynchronous, and there is a queue. And flow control prevents that queue to becoming too large. In Galera Cluster / PXC, it works in a way that it will tell, a node will tell, hey, I'm falling behind, please stop all your writes. That's basically the message that will be sent to the other nodes. So that's what we call a flow control message. And when it sent that message, all the other nodes will not longer process writes. They will just halt and wait until the other node is kind of caught up. The defaults in Galera is 16 transactions. That's very low. So if you have a little bit of lagging behind, flow control will be sent, everything will be halted. So that's why maybe that you can say it's more a synchronous solution, because it can only be behind 16 transactions at the cost of performance, of course. So there's less likely to read stale data because it's only 16 transactions behind. PXC, we recently, with the latest release, changed the default to 100. I'm added a star to the 16 because there's some math behind it. Depending on the amount of nodes, it might be 24, 32 that it does. It makes a calculation based on the amount of nodes. In Percona XtraDB Cluster, it's 100, so we can kind of lag up to 100 transactions. Group replication is completely different, their flow control implementation. So every node during the communication sends some metadata, and every node knows from the other nodes what is their queues. What did they not apply yet? And there's various queues in both Galera and MySQL Group Replication. And in Group Replication, you can configure flow control for both. Now, in this case, it's not I'm telling others to stop writes. No, it's more slow down your writes. So a master will process writes, but if it sees that another node is lagging behind, it will slow down its own writes in order to make sure that the other nodes can still keep up. So it's not like flow control message, I need, halt, I can't do it anymore, stop, all right, stop. So it slows down depending on some quotas, on some calculation, on how fast the other node can process the transactions. The default is 25,000, which is quite high. That's a big difference between Galera Cluster. So the good thing here is that it slows down instead of completely stops all writes. WAN support, group replication does not recommend this for wide area networks. Galera has some functionality. You can configure weighted quorum, which might be useful in your environment. You can tune more settings, more network communication settings. You can tune windows, you can tune timeouts. Group replication, you cannot at this moment. You can reduce network traffic between the nodes because all the nodes talk to each other. If you have multiple data centers, you can create 2 segments, and the data will only be transferred once to the other data center. So that's an optimization. There's also an arbitrator in Galera, which is basically a node that doesn't have the data. It's not running MySQL, but it speaks the protocol. And it can handle making the decisions whether or not a node is primary or not. So this is kind of useful in certain wide area networks for certain use cases. A short one, Galera supports FreeBSD and Linux. Percona XtraDB Cluster supports Linux, various flavors. Group replication supports Linux, Windows, Solaris, OS X, FreeBSD. So it's included in any MySQL version that they ship, any platform they ship, they include group replication. And the last difference is schema changes, DDLs. And in Galera Cluster / PXC, when I do a DDL, I do an alter table. It will basically the cluster will go in total order isolation, TOI. And all the writes will be blocked at that time. No writes will be processed during that alter table by default. There are various workarounds to not have to do this, and one of them is PT online schema change, so from Percona Toolkit, that will try to make schema changes online without having to do a big alter table. There's another method in Galera called RSU. So the default WSREP online schema updates method is TOI, total order isolation, and RSU is rolling schema updates. So what is this? Is basically alter tables will not be replicated between the other nodes, and it's up to you to go to all the other nodes and manually do the alter tables one by one, however you want to do it. You have to coordinate it yourself, but it doesn't work for like deleting a column. Because if there's a write coming in on the other node and the column is gone, it will not apply, and the node will see that its consistency is compromised, and it will just basically shut down, because these are systems that want consistency. So that's not happening. So that's quite, there's quite some improvement that can be done there. In group replication, DDLs don't block. There is no such thing, thank you, such thing as blocking all the writes. It just, the alter table is done. When the alter table is done, it will be replicating to the other nodes. However, you can create inconsistency. You can create crashes. You can crash the cluster if you run the same alter tables or similar alter tables at the same time on 2 different nodes. And you should only do this in single primary mode. Okay, so it's going. Yes, question, Alex. Then yes. So if you do, so the question is, if you do a DDL on one node and you write to other nodes, yeah, what's with the consistency? So yeah, will fail. Nodes will give errors because it cannot apply the row log event, and they will quit as well. Yeah. However, I saw some magic that they do. They kind of are compatible with various things, but I was able to kill it fairly easily. They want us to end already, I guess. Yeah, last call. We have a lot to do, but everybody seems active, so yeah. Other question? No? Okay. Then, differences between PXC and Galera. So, I've mentioned these first 3 already, but I want to go a little bit more in deep depth on the other ones. The first one is strict mode. So, the strict mode, as I mentioned, is to prevent these functionalities that are not supported or are experimental with Galera or with Percona XtraDB Cluster. So flush, transaction isolation serializable is a problem. You need primary key tables, you need binary log format row, and only InnoDB is supported. So this enforces this. So this is good. This is we have a lot of customers when we work in consulting and support that try to use these functionalities, but it doesn't work as expected, and then we run into trouble. So this improves usability quite a lot. The integration with ProxySQL is that we've got our schedulers, we've got a ProxySQL admin configuration tool that will configure the node, the ProxySQL nodes, and we also introduced a maintenance mode in Percona XtraDB Cluster, where basically it's just a flag that gets, okay, I'm going in maintenance mode, and then ProxySQL, or at least the integration that we have, will notice, oh, this one is in maintenance mode, I'm going to redirect traffic to the other nodes. So it automatically does that. But the maintenance node is just a flag that you enable. You can still do kind of all operations there, but it's just a way that we can change ProxySQL's behavior just with that flag. So that's quite nice. In terms of performance, here's something we blogged about this last week. We did a lot of scalability fixes in Percona XtraDB Cluster 5.7.17, and here's the difference between some benchmarking. Here's some benchmarking graphs. So we did some benchmarking here. That this is MySQL PXC 5.7.16, and this is PXC 5.7.17, and you can see there's a lot better performance for all LTP read-write, update key, and update no key. So we made various enhancements. We've blogged about it. We made a lot of blog posts. Read about it, how we did this, and why we did all these kind of optimizations. And we also changed a couple of defaults, and this is the kind of the defaults that we changed, and also in order to get this kind of performance. Now, some limitations quickly, and then I'll hand over to Ramesh, is that these things don't work. And you can see the strict mode is just kind of blocking all these things. Like select for update does not work as expected. Don't do alter table import export. It's not going to copy. It's basically importing your data files. Table spaces one by one. You need to kind of coordinate that with your node. So it's got to be careful things. There's a maximum transaction size, and that's capped at the moment, so it's configurable. Yeah, so large transactions not really great now at this moment, so it's capped. XA transactions are not supported. Group replication, and you can see, almost all the same. Large transactions are not capped. It's your own responsibility. It will nicely transfer gigabytes of data. However, I've already heard feedback from some of the developers there. The next release will have like a cap of 150 megabytes set. So they're doing work in order to support this. There's also some problems with foreign keys that might create inconsistencies at the moment for them. Nothing is perfect, of course, and here are some issues. This is just a couple of issues that we have with Galera Cluster at the moment. So we have some these are bugs, basically, right? So some background threats handling transaction processes. We have some crashes related to DDL. They're really, really rare use cases. Doesn't happen frequently, but I wanted to be honest because I'm going to show you some bugs from group replication. Of course, there are bugs in Galera Cluster and PXC, of course. We have some issues with concurrent DDLs and shutdowns. All of them, these are the bug reports on the codership MySQL Red, WS Rep issue 279, and so forth. Group replication has a lot of issues too, so I gave a presentation back in January about this. I filed about, I don't know how many bugs, here's a few of them. And there's some issues with hanging queries, with split brain issues. You cannot prevent writes on nodes if they cannot join the cluster because the node will become read-write. So a lot of partition tolerance issues, basically. If you stop group replication plugin, the node becomes read-write. These are like dangerous things because if an application still suddenly tries to write to it, split brain. There's also, client connections that get stuck. We have some stabilities issues with the large transactions and so on. A lot of them I've discussed again. They fixed some of them already. You can see the super read-only bug is fixed in 8.0.1. They might backport that, I think. There's some others that they're resolving at this moment. And the large transactions they're kind of fixing as well at the moment. You cannot kill a query that is stuck in group replication at the moment. There's one that is fixed already. So a lot of work has to be done at the moment. Now I'm going to give it to Ramesh. Just give him a couple more minutes. Sorry that we're running maybe a little bit late.
Okay, I'll go first.
No, you don't have to. For me, I mean, I have time.
So how do we make these solutions perfect? So it has a native MySQL test suite. So group replication has an extensive MySQL test suite. It does a lot of like membership checking, then recovery, state change, query handling, concurrency, stress, etc. But in Galera and PXC, it's not as extensive, but it has its own test suite, and it do query handling, concurrency, and stress testing, etc. So here is the main highlight we use to test the solution. This is pquery. It's an open source multi-threaded test program, and this is we have created for stress testing, and this solution works for any MySQL flavor, MariaDB, Oracle MySQL, Percona server, any flavor. And to test this cluster solutions, we have modified pquery framework to start 3-node cluster, and we fire SQL statements against these solutions. So it's a how do we make a random SQL? So we have a mtr to SQL script in our Percona repository, QA repository. What it does is just extract all the mtr SQLs from the mtr test suite, and we save it in one file, and we use these SQLs and fire against this cluster solution. So what is the features of this pquery? It's highly effective. In an hour, you will get plenty of core dumps, assertions, and fully automatic test case creation. And it's written in C++. And for testing this, we have every trials we run 120 seconds, and in 120 seconds, thousands of SQL will be fired against the solutions. Then if you have any sporadic issues, it is very much compatible to reduce that sporadic issues, and high-end automation, and it's a full framework we have created. And this is how it looks like. We have an SQL file, it picks random SQL, and pquery will fire against the solutions, and will if there is any assertions, report to us. So this is a sample group replication test run. So you can see we have initiated 1,000 trials, and these all are the unique assertions we got. So one of the assertion hit more than 200 times. And out of 1,000 trials, we got 283 times that particular assertions. And these are the, with this assertion, what pquery framework does is, it just reduced that particular assertions. And as I said, pquery execute thousands of lines of code against that group replication. And while after reducing this using reducer.sh script, we got 4-line code. So if you execute this 4-line code, you will get an assertion. Same as we have initiated 1,000 trials in PXC, and we got this many unique assertions. The same thing we have applied here, and we got 3-line code, and you can easily crash the server. So since to make the test case easy, we have created some startup script. So if you are not much, if you are difficult to face setting up these solutions, we have created some startup script. Currently, it works with only binary tarballs. So you just untar the binary tarball and you execute the startup script against that. So for PXC Galera, we have a PXC startup.sh script inside Percona QA repository. Just start that, just execute against from base directory. You will get start PXC script. If you want to start 5-node cluster, just run start PXC script with 5. It will start 5-node cluster. Same as we have created for group replication. The name is startup.sh. You just run start, and when you run this startup.sh, you will get a lot of scripts. One script is called start group replication. So if you run that, you can start if you mention 3, it will start 3-node group replication. So this is a sample run. So as since we Kenny said, we have created we have recently released a performance patch. So I'll show some of the performance difference while testing we got. So we have created a workload of 100 tables with 4 million rows each, and the data size approximately 100 gig, and we have tested with 3-node cluster, and we have initiated 3 different runs. One is sysbench OILTP read write, OIL update key, and no update key. So to get more information about this run, you can visit this blog post written by Alexei Stroganov. So these are the results we got while testing performance. So PXC with the latest patch, PXC is on par with group replication. In some places, PXC giving higher performance than group replication. So we have initiated 2 different runs. One is with sync binary log on, another is with sync binary log equal to 0. This is the difference. Okay, and another performance test we have performed is how cluster node joining speed shows. So what we have done is we have started 3-node cluster, and in 3-node cluster we just shut down one of the cluster node and inserted 1 million rows, and while joining back, how effectively it joined back. So this is the result. So the smaller is better. So PXC, due to SST, we have PXC node joining is giving better performance. Since MySQL Group Replication is using asynchronous replication method, it takes a lot of time. So that's about QA. So handing out to Kenny.
Thank you. And this is a slight summary of the things that we've covered today. So the 3 solutions: Galera Cluster, Percona XtraDB Cluster, and Group Replication / MySQL InnoDB Cluster. And you see it's kind of like the differences, the features that are there, that are not there, some of the issues. That's just a small overview. And I think the next slide was, yeah, see if you have any questions. We still have like 5 minutes before the raffle starts in the expo hall. Yes, sir. Group replication has a limitation of 9 nodes. Realistically, I don't know. There's not been much adoption in group replication, not that I've seen, and it's still relatively new, so I don't know about that. For Percona XtraDB Cluster, most of them run 3 to 5 nodes, and I have seen 7 nodes, but never in an environment where that was necessary. It's more like we have the hardware, let's just use the hardware. So 5 nodes is also quite something that we regularly see. But keep it uneven. We need an uneven amount of nodes. That's very important. Yes, sir. Yes? Sorry, did I not give you the thing? Yes? You want to take pictures? It will be on the website. We'll put it on there very soon. Perfect. Yes, sir. So, PT table checksum requires statement-based replication, which in strict mode is disabled in Percona XtraDB Cluster. It does not work in group replication because it requires binary block format row. If you run Galera Cluster or PXC not in strict mode, you can. But it has the same limitation as running a DDL. When a statement runs in statement-based replication, it needs to go into total order isolation mode, which means that all the other writes will need to wait because that single statement needs to be executed. Because it cannot determine whether or not there is going to be any conflicts. It basically needs to go like really serialize all the writes. So it has quite a big impact on performance. So in terms of tooling for that, at this moment, all these technologies, if they find that there is an inconsistency, the node will just shut down and basically in Galera terms, it will just say node consistency compromised, crash, stop MySQL completely. It will start up again. It will do an SST to get the whole copy of the data back and start. This is only in cases where there are bugs in the software that we have found over the years. But it's not something, you need to do quite a lot of things in order to get this kind of inconsistent. In group replication, unfortunately, it's a bit more easier at the moment. But yeah, as soon as they fix a couple of these issues with super read only, that you can enable super read only at start of MySQL, then I think this is going to be a lot better already. Yeah. Yes. So flush table for export should work. You can then export table spaces, but the only thing that I mentioned in the thing is that you need to be aware of the moving them if you add tables to it. That might be kind of like you need to coordinate that, but that should work. I didn't test yet, but from what I've seen, this is not blocked off. Yes. Okay, thank you very much. And Expo Hall is now for the expo, the grappling. Thank you.